In this video, we're going to learn how to use log properties, or the properties of logarithms, to condense expressions, to kind of squeeze them together. And so what I have is I have an expression right here, and I have all these log properties that we talked about in previous videos. And what we're going to do is we're going to use these to rewrite this, okay? So let's jump into it. The first thing that we see is, I see, and when I'm reading this left to right, that we've got addition right there. We have log base 2 of something plus log base 2 of something. And just with practice, I can recognize that that reminds me a lot of this right here. Log base 2 of x plus 2 plus log base 2 of x. Okay, that's exactly what we have over here. So I can do is I can rewrite those as a product. So let's do that real quick. I have log base 2 of x plus 2 times x. And then I still have this over here that I'm just going to copy down. Okay? And now what we have is we have log base 2 of something minus log base 2 of something. And so hopefully now you're seeing the second row of our log properties. Log base 2 of something minus log base 2 of something. I can rewrite that as division. Log base 2 of the quotient. So let me do that real quick. So I have log base 2. And now we have in our numerator x plus 2 times x, but now in our denominator we have a 5. And really at this point pretty much we're done. There's nothing else that I can really do here. I might simplify my numerator by distributing, so I have log base 2 of x squared plus 2x over 5. And I get that just by distributing, okay? Let's do another example. We're going to condense again, and this time we're actually going to have to use some other properties. So notice in these we have coefficients out in front, but in none of these properties we have coefficients out in front. I can't use either of these whenever I have coefficients next to the logs. And so what I'm going to do is I'm going to look right here. This is in a property that has a coefficient. And so if I have that coefficient next to my log, it looks like it can just kind of be the same as not having the coefficient, but making that coefficient an exponent. In other words, I can take that in and move it up to an exponent. Okay, let's do that for both of these before we jump into anything else. So this left term can become log base b of x squared. Notice I just took that 2 and made it an exponent, and I'm going to subtract log base b of y. I'm going to make that to the 4th power. Now that we're here, we can use our properties up above. Specifically here, since we are subtracting, we're going to use this property. If I'm subtracting one log minus another log, I can rewrite that as the log of the quotient. So I have log, oops, I'm writing in a highlighter, log base b of x squared over y to the 4th. And that's going to be about as condensed as we can get that one. Looks like I have one last example. Let's power through this one last example. It's going to be a little bit more complicated, but nothing too crazy. So what I have is, once again, it looks like we have these coefficients out in front. So let's deal with these coefficients first. Okay. So I'm going to rewrite that as log base b of k, but that k is to the 1/2 power. I took that coefficient, made it an exponent, plus log base b of 2j to the 3/2 minus log base b of k squared j. Now, let's deal with our addition, and then we'll deal with our subtraction. We're going to deal with this from left to right. So I have log base b of k to the 1/2 times 2j to the 3/2. And I'm going to subtract log base b of k squared j. Now, because of the subtraction, I'm going to make this this part over here is going to be in the quotient. Okay, or it's going to be in the denominator, I should say. So we have log base b. I'm going to recopy all of this stuff. and that's going to be over k squared j. Now, this is something that we could simplify. This is almost starting to look like an exponent properties problem because I can simplify all this, and maybe I should do that real quick. What I'm going to do is I'm going to rewrite this term. If I have a single term that's raised to a power, I know that that power applies to both the 2 and the j. So let's just do this real quick. So we have 2 to the 3 halves times j to the 3 halves, and that's going to be all over k squared j. And then my last step, and man, I'm running out of room here. I did not plan well. I am going to subtract exponents here, because whenever I have the same, there's just exponent properties there and exponent properties there. So if I subtract, I'm going to, let me create a little box here to write my final answer. So what I have is I have log base b. If I subtract 1/2 minus 2, I get negative 1.5, and a negative exponent goes in the denominator. I still have my 2 to the 3 halves, which I'll write as 1.5. And then here, 3 halves minus 2 halves, if I subtract those exponents, you would get j to the 1/2. I could rewrite those exponents as fractions, but I'm tired of looking at this problem, so there you go.